Alright guys, today we're going to solve this improper integral. Now you can determine if the integral is improper by looking at the degree of each polynomial in the numerator and the denominator. If the degree of the numerator is larger than the degree of the denominator, it's improper. We can see that's the case as we have 8x cubed, so x cubed, or I should say 3 is our degree, over 4x squared, so 2 is the degree of the denominator. So in this case we have 3 greater than 2, so yes, this is an improper integral. Now in order to change this into a proper integral, we're going to have to do long division. Where we're going to divide the bottom fraction, polynomial in the denominator, which is 4x squared plus 7, into the top polynomial, 8x cubed plus 2x. Now remember, when we do long division, we have to write out coefficients for each missing term of x cubed, x squared, and so on until we get to our constant. So 8x cubed plus 0x squared plus 2x plus 0. Okay, now we do the long division. So when doing long division, we start off by asking ourselves, what do we need to multiply this first term by to make it match this first term in the dividend? So we need to multiply 4 by 2 to get 8, and x squared multiply by x to get x cubed. So when we do that, we get 8x cubed. We must also multiply this second term here, so we get plus 14x. Okay, now we're going to subtract this line. When we do that, we can see the 8x cubed will cancel with the negative 8x cubed, and we get negative 12x. We have 14x times negative 1 is negative 14x plus 2x makes negative 12x. Now we check and see that this power, this degree, is lower than the divisor, so this now becomes our remainder. And our remainder we write as minus 12x divided by the divisor, 4x squared plus 7. This now means we can rewrite our original integral now as the integral of 2x minus our remainder 12x over 4x squared plus 7, whole thing multiplied by our dx. So this would be equal to now the integral of 2x dx minus, now in order to integrate this part of the integrand, I'm going to use U-Substitution. So I'd set U equal to 4x squared plus 7, then the derivative of U with respect to x would just be equal to 8x, which means the derivative of x, or I should say just dx, is then equal to du over 8x. So now substituting these values in, we have 12x, negative 12x over u times dx here we know is now just du over 8x. We can cancel the x's and reduce these coefficients to 3 over 2 by dividing by 4 each. And now we have the integral of 2x dx, which is simply 2 times x squared over 2, the 2's will cancel, minus 3/2 times the integral of 1 over u times du. So we now know this is x squared minus 3/2 times natural log of the absolute value of u plus c. And finally, we've remembered to substitute in or resubstitute what we had for u. So this would become x squared minus 3/2 times natural log. We can drop the absolute value because the term 4x squared plus 7 is always positive. And remember our plus c. So here we have it. This is how you integrate an improper integral using long division.